Hello students, today we will discuss about the application of OPAMP. OPAMP, operational amplifier. It performs various mathematical operations, so the name operational, and amplification is the basic function of the OPAMP, so it is called as operational amplifier. Physically available amplifiers is in the IC format, which is 8 pins, which has got 8 pins. We are using 2 input pins, that is pin number 2 and 3. It is a MU-A741 OPAMP. So it has got 2 input pins. One is inverting input terminal and other one is non-inverting input terminal. Pin number 6 is used as output. Pin number 4 and 7 are used for biasing voltages, that is VCC and VEE, or it is also called as the saturation voltage for biasing the transistors present in the OPAMP. Today, the basic application of OPAMP is shown here, which is called as voltage follower. Basically, voltage follower is a concept of non-inverting amplifier. It has got non-inverting input terminal as the input supply and other input terminal is taken as a feedback path. That is, inverting input terminal given to the pin number 6, that is pin number 2 is connected to pin number 6 so as to get the feedback path. The basic equation of operational amplifier says that voltage gain AV is equal to 1 plus RF by R1, that is 1 plus feedback resistance divided by the input resistance. To convert that non-inverting amplifier concept into the voltage follower circuit, we have to take the resistance RF equal to 0 and the input resistance R1 equal to infinity, so as to make the ratio as 0, that is 1 plus 0 equal to 1. Altogether, voltage gain AV is equal to 1. Let us see how it happens. I am taking the MU-A741 OPAMP and continuing the experiment to show or to prove that how OPAMP can be used as a voltage follower. So the basic components required here are to build the circuit is, one is MU-A741 OPAMP, and the springboard or a breadboard can be used to mount this particular IC, and some amount of wires to make the internal connectivity. A signal generator is used where different types of and different frequencies of signals are generated here. One fixed power supply to bias the OPAMP, that is VCC and VEE are provided by this particular DC power supply unit, and along with that we have ground point in the same unit, and cathode ray oscilloscope where we can study and to analyze the various wave formats, the input wave format as well as the output wave format. We can bring the comparison between the two input and output waveforms and come to a conclusion. So I'll show how to establish the connection here. Take a springboard or the breadboard. I'm taking a springboard here. There are 2 different slots here for connecting the IC. It has got a 16 pin package, dual inline package. It is a zip format. So I'm taking the upper part of this. I'm mounting the IC. How to mount the IC? That is very important here. The IC has got 8 pins. From which side we have to take the pin number counting. So here we have one particular dot. It is called as a notch. Every IC has got its own particular type of notch. So that notch says that from this particular point we have to start taking the IC pin number. That is from the left, from this part. See, I'll show you. This is pin number 1, then 2, 3 and 4, 5, 6, 7, 8. That is how the IC numbering is counted here. So I'm taking this particular IC, mounting it on the IC holder and locking it. So now the IC mounting part is ready. Now I have to make the necessary connections so as the OPAMP can be used as a voltage follower. First, let us connect the supply voltage. There are 2 supplies, that is minus 12 volts and plus 12 volts. Minus 12 volts is called as VEE, that is a negative biasing voltage for the other transistor present in the IC. So it is connected to pin number 4. Connection is made, pin number 4. Next is plus VCC. So that is to pin number 7. This indicates that now I have properly biased the IC, that is the transistors present in the particular IC is biased properly. Next, what is required? The input is required. So input, how to set the input? First take the signal generator, turn it on. What voltage is required? The experiment name says that it is voltage follower. Whatever you apply at the input side, that will be following at the output side, or the output follows the input. So it is called as unity gain amplifier, or it is a voltage follower. I am taking one reference value, taking a sinusoidal signal of a frequency 1 kilohertz. 1 kilohertz sinusoidal signal is set. What is the voltage required? That we have to set. So for that I am taking the probe from the signal generator and connecting it to the CRO, cathode ray oscilloscope, where we can see or observe the waveforms obtained from the signal generator. The connection is made like this. The positive ends of both the probes from the signal generator to the CRO is connected together, and negative, that is a black wire, are connected together. It is called as a ground pin also, or negative. So once you connect it, make arrangements in the CRO screen. Again, I made some arrangements, I made some adjustments to avoid that. Press ground pins of the CRO, both the channels, and bring the lines to the center. Okay. So now both the channels are set to 0 level. Now release the ground button. Now you can see there is a waveform starting from 0. I'll just move this other channel which is not required right now. Waveform is swinging with respect to this particular ground line, that is positive cycle as well as negative cycle. That is how it is set. Now you can amplify or maximize the signal by multiplying or varying the multiplication factor for the voltage division, and enhance the signal by changing the multiplication factor of this particular time division. That is milliseconds division we have, microseconds division we have, here the voltage division we have. That is for voltage multiplication, and here the time multiplication, that is a frequency can be enhanced. It is not the frequency of the signal. The applied input signal is 1 kilohertz only. I am just observing the voltage now. So to observe the voltage, I will set it to 1 volt division so that I can multiply it very easily with the divisions. See here, and if you observe here, the total voltage from this division to this division is 1. It is something like the graph sheet. It is 1 by 1 centimeter graph. So 1 division into 1 division we have multiplied by this voltage division. It is set to 1. So 1 into 1. So it is 1 volt. How to make it 2 volts? I will just increase the amplitude button present in this particular signal generator. If the signal covers 2 divisions and the multiplication factor is 1, so it is 2 divisions into 1 volt, 2 volts. So this is how the voltage is set. Next, we will apply this particular signal to the input terminal of the OPAMP, that is pin number 2. The non-inverting input terminal, pin number 3 is taken as the input terminal. Connect here. Output is observed at pin number 6. So I am connecting it to pin number 6. Yet I did not turn on the power supply because the circuit is not on yet. I just set the input voltage. There is one connection required to bring this particular circuit to the closed loop format. That is, if any part of the output is brought back to the input, then it is called as closed loop. Its gain is controllable. If the path is not established from the output to the input part, then it is an open loop configuration where the ideal gain of this particular open loop configuration is infinity. But we don't have infinity term, so we range it from 10 raised to 4 to 10 raised to 6. That is the gain of open loop op amp. So pin number 2 is connected to pin number 6 of the OPAMP through a wire, a piece of wire. Now the closed loop path is established. The remaining part is taking the referral ground. This IC does not require any ground, but we have the black probes, that is the negative terminals of the probes which require ground. So I am taking one independent node. So this is independent node right now because IC is connected here. So I am taking this independent node. So this is not connected to anything, it is just a node or a point. I am connecting this negative terminal of the probes to this particular ground pin. So this ground is established from the power supply itself. So circuit is almost done. I have to take one particular reference, that is called as the comparison voltage. What output I am getting with respect to what, that has to be shown on the screen. Whenever you are comparing any signals, there should be a referral input. So I am taking that referral input from pin number 3 itself, that is the input. So this is how the circuit is done. Now we will turn on the supply, that is the biasing voltage, and bring the output. Here you can see a single wave. Actually it is a superimposed waves. I will show two different waveforms. See here. So one is input, other one is output. Channel number 1 is taken as the output, channel number 2 is taken as the referral input. The input and output are showing the same value, that is applied input voltage is 2 volts, the available output voltage is also 2 volts. This is a simple proof for voltage follower. Now we have to check for different values and different waveforms so that we can conclude that it is a voltage follower circuit itself. So for that I am increasing the signal strength. See that the corresponding signal strength is increased. See, I will just reduce the voltage division so that we can go for different values. Now the division is 5 into, it is covering almost 1 division, so it is 5 volts. Here also we are getting the corresponding voltage. I am increasing, it is now around 2 point something volts or 2.1 divisions into 5, it is 11 volts, and so on. For any value of the applied input voltage, output is following the input. And what type of waveform? Ideally we take sinusoidal signal. If I don't want sinusoidal signal, go for different waveform. We have the button here called the waveform. If I press this, I am getting square wave. See here, corresponding square wave is shown. This is output, this is input. So both are identical. Again, if I don't want square wave, I can go for triangular wave. It is one more type of waveform. Or I can go for pulse. So how pulse is different from square wave? The duty cycle of the pulse. See here, pulse width can be varied. This is the minimum pulse width and this is the maximum pulse width. Again, the output and input are resembling. It says that this is a voltage follower circuit. This is a proof that OPAMP can be used as a voltage follower circuit. There are different applications of OPAMP like inverting amplifier, non-inverting amplifier, and different mathematical operations that can be performed using your operational amplifier. That will be discussed in the further classes. Thank you.